Today we're going to look at lesson 11. Now, we don't have a specific I can statement or learning objective today because we're doing a couple different things, but we're just going to call this lesson More Polynomials. So we're going to build off of in behavior and multiplicity that we talked about yesterday. And so you'll hear me refer to those, especially the multiplicity. We're going to look at it quite a bit more today and what that means and what that looks like and how it helps us when working with polynomials. So we're just going to jot a few notes down here. Okay, sorry about that. Got a phone call, just like normal school. So, I don't remember exactly what I was saying to you before the phone rang. But hopefully this is close. We're going to jot down a few things, and then I'm going to work through the problems in your Math Excel work. So I've printed out the sample. I'm going to work through those and show you how to do them, because I think that's the best way to do it without overloading you with examples and showing you stuff that you don't need. I'm trying to really condense it and show you what you have to do the assignment. And then I will have a blank copy of these examples loaded in Google Classroom, so you're welcome to print those off and work through them with me as we go. But that's up to you. That's completely optional. And then I will also have a separate video showing you how to do some stuff in the calculator in Google Classroom. So make sure you watch that one as well. It's going to be pretty helpful for you. Okay, so let's get started. Okay, so the first thing that we need to talk about, and I know I've said this before, but when we're talking about polynomials, especially when we were talking about quadratics, when you hear solutions, roots, zeros, those are all referring to the same thing, okay? And when we're talking about zeros of polynomials, if we have real zeros or real solutions, those show up as x-intercepts on the graph. So those x-intercepts are the real zeros. You can also have imaginary zeros. We figured that out when we were solving the quadratics. You could have answers with I, and those zeros would show up over here, like where it's floating and not touching the x-axis. There is where your imaginary zeros would be, but your real zeros show up as x-intercepts, and so that's extremely, extremely important, and we're going to use that information today. So your real solutions, your real answers are x-intercepts on the graph. Okay, now we talked about the degree of a polynomial. That's the polynomial's largest exponent. So when you're looking at the polynomial's degree, or the highest exponent, that tells you how many zeros or how many solutions there are. Those solutions don't have to be unique. They can be repeated over and over, okay? So if you say you have a polynomial and it factors to this, that means that you have x minus 2, x minus 2, x minus 2, and x plus 1. If you solve each of those, you're going to get the same thing. You're going to get x equals 2. But there's no need to write out x equals 2, x equals 2, x equals 2. You can just write it once and use the exponent, okay? So here, this is 3 and 4. So that's 4 total zeros there, okay? So the degree of this polynomial would be 4, okay? So that's just showing you that they don't have to be unique. We'll look at something like that a little bit later, and we'll talk about it more, okay? And here's an example. When we were doing quadratics, if we set a quadratic equal to 0 and factored and solved, a quadratic has an exponent of 2, or a degree of 2, and we had 2 solutions, so that matches up. Degree of 2, 2 solutions. Now, before we move on to the next little thing, remember we talked about the multiplicity yesterday. So we're going to make a little note here. So you're going to hear me refer to the multiplicity, okay, of the zeros, or of those factors. So you look at the exponent. So the multiplicity of this one is 3. Of this one, it's 1. So this 0 happens 3 times. This 0 happens once, okay? And then we talked about what happens at those x-intercepts if their multiplicity is odd or even. So remember, if it's an odd multiplicity, it goes through that intercept. If it's even, it turns or bounces back. Okay, so we're going to use that information again today. So we wrote it down yesterday, but you can make another little note of it here. Odd multiplicity, it goes through the point. Even, it turns or bounces at that point. Okay, and so we're going to be looking at those in some graphs today. Okay, now there's a theorem in algebra, and it really makes everything that we're going to do today possible. We're not going to worry about the name. We're not going to worry about writing out the actual formal theorem. What you need to know is if A is a 0, then x minus A is a factor. So that means if your x-intercept is -3, then x plus 3 is a factor. So an example of that would be if I get x equals 2, then the factor x minus 2 is a factor. Okay, so we're going to use that a lot today. A lot of what we're doing hinges on this being true. So it's important just to make a little note of it, just to be aware that that is true, and it comes from a theorem that's been proven. Okay, the next thing we're going to talk about is a maximum or minimum. Depending on what your graph looks like, you could have a maximum, you could have a minimum. When we talked about parabolas, and we can come over here and make a note, if your parabola looked like this, you had a minimum. If it looked like this, you had a max. And if you want to make a note there, that might help you, because you can kind of apply that to other shapes. All right, but what we're going to be looking at today, in some of your problems, it's going to say find the relative maximum or the relative minimum, okay? So you need to know the difference. Now, depending on what you're looking at, you could see some different vocabulary. Relative is the same as local. Absolute is the same as global, okay? So relative means in relation to a smaller portion of the graph. So if I was looking here, you can just sketch out this shape. Obviously, this would be an even polynomial, even degreed polynomial, because both ends are going in the same direction. We talked about that yesterday. But if you look at this little portion of the U, it looks like this. So we could have a minimum there, but it's not the lowest point on the graph. It's a relative minimum because it's the lowest point in relation to this portion of the graph. Okay. Now, if I wanted the absolute minimum, then I would go here because that is the absolute lowest point on the graph. Okay. So, just be aware that's what that means. I'm going to show you how to find these in your calculator so you don't have to worry about doing these by hand or graphing these by hand. If this was asking us for a relative maximum, we could say that this is a relative max here. But if it asked us for the absolute max, we couldn't find it because we don't know where the graph ends because it keeps going up forever and ever. So we're going to talk more about max and mins. You can make yourself a note. I'm writing it here so I don't forget to say it to you. Use your calcs for the max and min. Again, don't worry about doing it by hand. You can use your Desmos calculator or the TI Inspire calculator. If you haven't picked up your Inspire, use Desmos. It's the easiest. If you have your Inspire, it would be good to practice with that because that's what you can use on the ACT. And then I'm going to have separate videos in Google Classroom. So I'm not going to show you how to do the calculator stuff in this video just because it's hard to switch back and forth between recording this and recording my screen. So I'm just going to make separate little videos for that, but they won't be very long. All right, so now we'll get into today's Math Excel work. Okay, so number one, we're given the factored form of a polynomial, and it says to find the zeros. So we do this the same way we found the zeros of or the solutions of our quadratic equations in the last unit. You just set each of these equal to 0 and solve. Okay, now I'm not going to write out all the work because I don't think you guys need it. You know, if you subtract 3, you're going to get -3. If you add 5, you get 5. If you add 6, you get 6. So we're just going to list them out. So -3, 5, 6. And it tells you use commas to separate answers. All right. And we're going to do the same thing with number 2. So the zeros are going to be -2, 4, and 6. And then we choose the correct graph. So you're going to find the graph that has x-intercepts at those places. So we're looking for -2, 4, and 6. So it looks to me like it could be, see, that one has -2, 4, and 6, and so does this one. But let's think. So the end behavior is what we need to look at. So on this one, x times x times x would be positive x cubed. So it's a positive. So your end behavior, your slope is positive. So I'm going up to the right. So D should be your correct answer. Okay, number 3, write the polynomial function in standard form with the given zeros. Now, you can do this a couple different ways. You can list out the factors and then multiply them out. So you could do x minus 2 times x plus 2 times x plus 3. But that's a lot of work. So let's do a shortcut. How many zeros do we have? 3 zeros. So that means it's going to be x cubed. All right, so you can look through here, and it says in standard form, so we can eliminate the ones that are not in standard form. Standard form, the highest exponent comes first, so we can narrow it down to these two, okay? And so this one, the only thing different are a couple signs. So let's think about it. What's 2 times -2 times -3? You should get positive 12, and so positive 12 is B. Actually, guys, so sorry, I was looking at the wrong thing. Forgive me. Show me some mercy there. These are the ones you're multiplying. So -2 times 2 times 3 gives you a -12, so C is your correct answer. Sorry. I was thinking multiplying them together, but you don't multiply the solutions together. You would multiply the factors together. So again, I apologize. So that's a quicker way to figure out the answer than actually doing the distributive property and simplifying this out. If you have 3 zeros, it's going to be x cubed. Think about the opposites of your solutions or what the factors would be. Multiply those constants together, and it gives you your end value. Okay, number 4, find the zeros of the function, state the multiplicity of multiple zeros. So this is a little bit different. You have a couple different problems like this in your Math Excel work today, but the first thing we need to do is factor this. So first we look for any common factors. I can pull out a 3x, and that leaves me with x squared minus 1. Now, what do we know about x squared minus 1? That is the sum, not the sum, I'm thinking the wrong thing. That's the difference of 2 squares, okay? Okay, so the difference of 2 squares, we can factor that out until we get 3x, x plus 1, x minus 1, okay? We set each of those equal to 0 and solve. So we're going to have 0, -1, and 1. And we need to know their multiplicity. So each of these just have an exponent of 1. So we're going to choose A, the numbers 0 or -1, 0, and 1. That's what we got there. Are zeros of multiplicity 1. So exponent of 1, multiplicity 1. Set each of those factors equal to 0 and solve. And I just put them in numerical order because I think that's how Math Excel likes it the most. Okay, number 5, find the zeros of the function, state the multiplicity of multiple zeros. So we've got x minus 4 and x minus 3, so that's going to be x equals 4 and 3. So the distinct zeros are 3 and 4. And then the multiplicity of the repeated zero. So this one is repeated, and it has an exponent of 4. So the multiplicity is 4. That means that that zero happens 4 times, okay? But it's repeated, so we're not writing it out a bunch. We just do have the exponent of 4, and that's the multiplicity. Okay? We're going to come back and do number 6 in the other video. We can do it in the calculator. So I will come back to that one in that separate video. I'll do the same for number 7. So look for that in the video as well. All right. Number 8, find the zeros of the function, state the multiplicity of multiple zeros. So this one we're going to do just like we did earlier, factor it. We can pull out 4x, and we're left with x squared minus 1. We can simplify that to x plus 1 and x minus 1. And the answer is the same that we had before. Multiplicity of 1. And our zeros are 0, -1, and +1. I'm going to put them in numerical order. Okay. I don't think you have to. I don't think Math Excel will be that picky. I can't remember. But you can put them in numerical order if you want to. All right. Number 9, the graph to the right is a complete graph. It's continuous, displays the functions in behavior. All zeros are integers. Answer the following questions. So list the zeros whose multiplicity is even. So remember we talked about even and odd. So even means it bounces back. Odd means it goes through. So find your x-intercepts on the graph. Okay, all of those pass through. So that means none of them are even. So you're going to say B, there are no such zeros. There are no even zeros. Okay. Oh, I skipped down. So there are no zeros. I didn't realize that there were 2 parts there. So sorry. I forget on here. On Math Excel, it just shows you one question at a time. And sometimes I forget that when I'm looking at the actual paper. Okay, so list the zeros whose multiplicity is odd. These are odd because they pass through. So let's see what those are. So this is -2, 1, and 5. Right? Okay. I knew that wasn't looking right. Guys, I can't even count today. What is wrong with me? This video is not going nearly as smooth as I wanted it to. So -2, 2, and 6. If we were in person, surely somebody would have caught that before I did. Surely somebody would have helped me out there. Okay, so moving on. We didn't have any zeros where it bounced. They all went through. So we just found those numbers, listed them out, and then write an equation expressed as the product of factors of a polynomial that the graph might represent. Use a leading coefficient of 1 or -1. Make the degree of f as small as possible. So first of all, we need to think about the end behavior. So our graph is going like this. So that means that it's positive. So our leading coefficient is 1. We don't have to do anything. We just need to make the factors. Okay? We've got our zeros already, so it's going to be pretty easy. It's just x and the opposite of what it seems. So x plus 2, x minus 2, and x minus 6. That's as simple as it can be. You can do that anytime. Anytime it asks you, we don't have to know the exact polynomial, the exact function of the graph. We can just do our best guess based on the factors and the zeros that we're given. Okay, and it wants to know what the y-intercept of the graph is. So we would do that by plugging 0 in for x. You could, if you can estimate really well, you could look back up at the graph and estimate, but it's between 2 little tick marks. So the easiest thing to do for the y-intercept, x equals 0. So if you put 0 in those factors, that would be 0 plus 2 is 2, 0 minus 2 is negative 2, and 0 minus 6 is negative 6, you can multiply that out, and I think you get, let's see, negative 4 times negative 6 is 24. So you just write or type that integer in. So we're basically just taking our factors, subbing 0 for x, multiplying it out. Okay, number 10 is very, very similar to what we just did. We are finding the zeros that are even, finding the ones that are odd, writing the equation as factors, and finding the y-intercept. So we take a look here, and we need the zeros whose multiplicity is even, so that means it bounces. So here's one, so that's at 2. Okay, 2 is where we have an even multiplicity. Negative 1 is where we have an odd multiplicity because it goes through. And then our factors, so x minus 2 and x plus 1. Okay, and it just says the product of factors, so we can leave it there. But if this has a multiplicity that's even, we can't leave it as just x minus 2. We have to have an even exponent. So what's the smallest even number? 2. So just throw that 2 on x minus 2 to give it the correct multiplicity. Okay? And again, our graph is going up. Our slope is positive. So our leading coefficient is just a 1. We don't have to do anything else. Find the y-intercept. Again, if you're really, really good at reading graphs, you might be able to estimate it correctly. But we'll plug 0 in for our factor, for x and our factors, and solve. So 0 minus 2 is negative 2 squared. And then x plus 1, or 0 plus 1 is 1. So that's 4 times 1 is just 4. Okay, number 11, we have one more like this. I'll walk you through it just because, but if you printed out the paper, I would love for you to try this one on your own and then check your answers with me. So we need the zeros whose multiplicity is even. So if you look here, it bounces here, goes through here, and goes through there. So the only one that's even is negative 1. Odd, we have 1 and 2. And then we need to make our equation in factors. So x plus 1. And remember, if it's an even multiplicity, what do I need to add on? The exponent of 2. And then x minus 1 and x minus 2. Okay, then we can find the y-intercept, plug 0 into those factors. So 0 plus 1 is 1, so that's 1 squared. 0 minus 1 is negative 1. And 0 minus 2 is negative 2. So that's just 1. So negative 1 times, okay? And so that gives us 2. If you look at your graph, does it look like our y-intercept is 2? No. What does it look like our y-intercept is? 8. So if our y-intercept is 8, how can I turn this 2 into an 8? That must mean that the multiplicity on this factor is not 1. So what's another odd number? 3. So what's 2 to the third? 2 times 2 times 2? Oh, that is 8. So that means that we would need to put a 3 on that factor to make that odd multiplicity, and to make sure it matches up when we get that y-intercept. So now I didn't realize that when I looked at the problem just real quick before we started this, or before I started the video. So I'm actually really glad we worked that one out, because if we hadn't, I would have just left it as x minus 2. I wouldn't have realized, I wouldn't have taken the time to notice that we have to change the multiplicity of that factor to get the correct y-intercept. So I'm assuming that your problem in Math Excel will be very similar. So double check that when you get to this problem. Make sure that your y-intercept on the graph matches what you think it should be when you plug 0 in for x. Okay, our last problem. Write a polynomial function that imitates the end behavior of the graph. The dashed portion indicates that you should only focus on the left and the right, those end behaviors. So let's think about it. So we said even has the arrows going the same way. Odd has them going opposite ways. So these are going opposite, so it has to be odd. So we can eliminate the first one and the last one. Now, the middle two both have odd degrees, but the A is positive here and negative here. So we said if our slope is positive, so if we look from left to right, it's going up from left to right. So that's a positive slope. So that means we're going to choose that second option there. So here we just looked at the ends and if A was positive or negative. So you'll do that same thing in your Math Excel work. Now, I apologize that the video was not as smooth and flawless as I wanted it to be, but we had some good learning moments there. And if you were here in person, it would have been so much easier to walk through this with you. But hopefully all is well. Use these notes, examples to do your Math Excel work. If you need help or have questions about anything, please let me know. If I didn't explain something well and you need me to re-explain it, I would be more than happy to do so. You just have to let me know. But with that, send me an email, hit Ask My Instructor, rejoin the Google Meet, whatever you need to do if you need me. If not, have a great rest of your day.